Hi students, in this lecture we're going to talk about a couple, in the video series, a couple of videos, we're going to talk about a couple design patterns that Chapter 12 uses to work with our database. So we've already worked and built our database context, so now we're going to implement a couple design patterns to make working with it a little bit easier and maybe add a little functionality to it at the same time. So what exactly is a design pattern? So design pattern in software development is essentially a pattern that we can implement or that we can deploy that can solve a lot of problems or essentially the same problem but maybe in different code bases. So whenever we do a design pattern, maybe you have a website that connects to a database um, and then or a web service that connects to a database, and then perhaps you build a different website or web service over here as well that kind of does the same thing but works with different tables. So we can use design patterns to deploy to essentially build consistently across our applications. And design patterns aren't necessarily a hard and fast rule. A lot of people uh, implement or deploy their design patterns a little bit differently, put their own little spin on it or whatever. There's tens of hundreds of design patterns out there. There's a few main ones. Uh, you can simply Google software design patterns to see exactly what they all are and what they all do. We're just going to talk about a couple in this video series. The first one being the repository design pattern, and essentially what that is it's going to wrap around our database context. So our database context, well, we will use to interact with our database, and the repository design pattern will uh, be an abstraction layer over that we'll use um, to call different tables in our database. So we're going to first genericize our database to be able to work with all the different tables. So let's say we have 10 different tables in our database. Well, we're going to use the repository to abstract away exactly which table we're working with. So we can call the repository and tell it exactly which table we want to work with, and then be able to use those insert, update, and delete statements from there. So let's go ahead and jump into Visual Studio Code and see exactly what I'm talking about here. So we're going to open and continue working with our book database, or our library kind of application that the book uses in Chapter 12. So we already went through and used Entity Framework for that. I also added in a couple different things the book uses. The first thing I added in was this query options class. Um, this is a class you can pretty much copy and paste or build into your code. Um, it is important to understand a few of the things that this class is doing. First and foremost uh, being able to order by and filter your result set. So you can see that we use a few functional techniques here to filter and order our result set. You see we can pass in a um, you see we can pass in a function here and a function here that will then order by and filter our result set. There's also different things such as pagination we can build into how we query our results. Maybe we just want the first or second page if displaying it on a web page. And then we also build in a couple properties to make sure that we have a where or order by function that's being called so we know whether or not it needs to be used. So that's all that this is. It's just a little helper class to uh, query our results is coming from our table. There's also an extension that is built in from the book that I included as well. So you see we include the iQueryable interface, which essentially allows us to query our results. And so we're doing a page by extension. So we're doing an iQueryable of whatever we're querying. So in this case, it's T, which just is essentially telling the compiler that this is generic. It can be any class. And then we're saying this iQueryable. So if you remember how we do extension methods, we're extending iQueryable of T, so the generic iQueryable method. And then we want to pass in the page number and page size that we're doing here. So So if we pass in, for example, page number 2, we want to then skip the first few pages. So let's say 2 minus 1. So we want to skip page 1 times however many page size we have, and then we want to take the page size, which is just a method built into LINQ that just tells it how many of the sample set we want to pick from or take. So we want to take however many the page size tells us. So it's, for example, 10. Just take 10 of those because the next time we call it, say with 3, we'll want to skip the second page times 10 and then take those 10. So that's essentially all this method is doing here. It's extending our iQueryable interface. So from there, what we want to do is now implement our iRepository design pattern. So let's go ahead and I'm going to build everything in our models folder here. It'd probably be best to break it down into subfolders from there, but I'll just skip that for now for the sake of simplicity. So I'm going to go ahead and build an interface iRepository, and this will just be a simple interface for the layer that will sit on top of our data tables. So let's go ahead and say namespace will be the bookstore models, and then we'll go ahead and give it a public interface iRepository. And now that we have our iRepository, the book also implements some filtering on it. So we want to say this is going to be iRepository of whatever class. So iRepository of T, so this is going to be generic. And then we're going to say where the T is a C# class. So we only want to allow people to implement this interface if it is a C# class, where the T is a C# class. So it can't be an integer or a decimal or anything like that. So from there, we're going to implement all of the methods that we want to use in our repository class. So the first thing I want to do is be able to query. So I'm going to say list my query based on my query options. So remember, we can list and order by. So if you remember our query options class that I had come over from the book, I'm going to go ahead and pass in those query options to pass back a list. So the next thing I want to do is I want to be able to get something from my list by an ID. I want to insert into my table. Again, it's generic, so it can be anything. So I'm just going to say T entity. And the same with update, T entity, void delete, T entity, and void save. So for some reason, my Visual Studio Code is kind of messing up. So I've been having to do this recently. So I need to restart OmniSharp because it's not giving me any IntelliSense. So OmniSharp is the part of the C# extension that gives you all your IntelliSense and your code lens. You see when I restarted it, now I'm getting some errors here. So I need to import my IEnumerable. And I think that should be the only thing I need to incorporate here. So now that I have my interface, I'm going to go ahead and build out my repository based on that interface. Let's go ahead and say repository.cs. Okay, so now I have my repository. Let's go ahead and give it a namespace of bookstore.models. And then let's give it a class name, public class repository. And it's going to be a repository of T because it's going to be whatever table we're working with. And we're going to implement our repository of T. And we're going to say this repository is going to, the T is going to be any C# class. So the T is going to be any C# class, so it's going to be our book, our author, our book authors, whatever the case may be. So let me go ahead and again restart OmniSharp so it can give me some error messages here. It should be giving me an error on my I repository to implement it. So here's my code lens again. Let's go ahead and import a using statement. I really shouldn't need that using statement. I just gave it the wrong namespace. Let's go ahead and get rid of it. And implement the interface. So now we see that I've implemented the interface. So the first thing I'm going to do is implement all of my void methods here. So when I call update, really the only thing I want to do is call, I might not be able to do this yet actually, because I need to give it my database that I'm working with. So in my repository, let's go ahead and generate a constructor. And I also want to bring in my bookstore context, which will be my database. So let's go ahead and give it protected just so it can only be accessed in this namespace or anything that inherits from this, I'm sorry. Let's say bookstore context. Let's give it a name context. And let's give it a couple of getters and set, or give it a getter and a setter. So now that we have the bookstore context, the next thing that we want to do is set whatever data table we're working with from that context. So let's go ahead and say db set of t, and that's going to be the data set we're working with. So within my constructor, first I need to import my Entity Framework core. So inside my constructor, I need to pass in the bookstore context. And then go ahead and say the context, so it's being dependency injected in, equals my context that's being dependency injected in. And my db set will be equal to the context dot set whatever context, oh, it's a method. So whichever type was passed in, I want to set the table I'm looking at to that context. So whatever t is, set the context to that table. Okay, so now that we have that, I should be able to implement a lot of these methods fairly simply. So the first thing I want to do is say, whenever I call update, I want to do a db set dot update the entity. So if they update the entity, what they're still going to need to do, whoever works with this repository, they'll still need to call save. So they'll still need to call context.saveChanges. And they're able to do that since I've implemented a save method here as well. So let's go ahead and do a few more of these. So db set.add entity. db set.remove entity. And I want to go ahead and group these next to each other. There we go. Just so we can read our class a little easier here. What does it not like about this? Already defines insert. Okay. All right. So our class is looking a little better. I'm going to go ahead and make these virtual like they do in the book, just in case anything tries to inherit from this, they're able to override the implementation. And they also make the list virtual and the get virtual. So let's go ahead and do that as well. So the get is going to be another fairly simple one we can implement. In the get, all we're going to do is do dbset.find the ID. And we'll move that to the bottom as well. So this is kind of also a facade design pattern, because a facade design pattern is essentially if you don't like the name of something, you just wrap it with another class and change the name and simply call the method. So it could also be an argument for the facade design pattern as well, but that is kind of outside of the scope of this class. So the last thing we need to do is our list, which is a little bit more complicated. So the first thing we need to set up is our iQueryable of T, which will be our query. And we're going to go ahead and set that equal to our table. So we'll need to import our system.link, which encapsulates the iQueryable interface. What does it not like about list? Oh, not all code paths return a value, which we'll fix here in a second. So the first thing we need to do is we're going to do a for each loop. So for each item in my options, what I want to do is include any foreign keys. For each include in my options.getIncludes. I'm going to go ahead and say query equals query.include that foreign key. So the next thing I'll say is if options.hasWhere. So if you remember, we had a Boolean that was essentially telling us whether or not this where clause had a link statement sent to it. So if it's null or not. So if it's not null, we're going to go ahead and add it to the query. So query.where, and then we'll go ahead and pass in the query from our options. And we'll need to do that for the has order by and has paging as well. So if the options has an order by, let's go ahead and add it to the query. Options.order by. If the options has paging, then we'll go ahead and add it to the query. And remember, this is actually the extension method, so if you are implementing this design pattern, you will need to implement the page by extension method. So we'll need to send it the page number and the page size so it knows how to page. And then we can return the list, or the IEnumerable of whatever we're working with here. Okay, so now that we have our books, how do we, now we really don't need this context inside our controllers. So now instead of our bookstore context, we can say private repository of whatever type that we want it to be. So let's go ahead and say repository of book. And I may need to include a models namespace. Where T is a book. Let's go ahead and give it a name. Okay, so now we have a repository that we're just working with our book table. So we can go ahead and say data equals new repository of book. So again, we're working with our book table, and I think we actually need to pass it our context. So since I'm receiving a context, I can go ahead and pass it in. And now whenever we need to work with our repository, we can simply say var books equals data dot say list or get, or however we want to get the books. Let's just go ahead and say list. And then remember, we need to pass in those query options for our book. And then here's where we can pass in maybe our order bys or whatever we want. So we can go ahead and order by. We'll go ahead and say b dot title. So that's how we can use the repository design pattern. And then the next video, we'll cover how we can use the unit of work design pattern. So the unit of work design pattern is essentially allowing us to encapsulate all of those tables into one class that will then be used to work with each table simultaneously. So I'll see you in the next video.